Okay, today we're going to be looking at the many different ways in which we can represent proportional relationships. Now, proportional relationships is all that we've been talking about for this chapter. So, for example, our unit rates, these are proportional, and when we find the unit rate, we find the constant of proportionality, which is 3. It's the same across the board on the table. And we can write an equation. So we've actually seen 2 or 3 of the different ways in which we can represent proportional relationships. We can look at it in a graph, we can look at it in an equation, and we can look at it in a word problem. So we are now just missing the graph, okay? So we're just kind of building on what we had talked about before. So let's just do a little bit of a review. A proportional relationship has a constant ratio between the two quantities called the constant of proportionality. So again, we're looking at a constant rate, so like unit rate, the constant of proportionality. This constant represents the rate of change. And we know from our previous lesson that that is also the unit rate, which is the ratio of the amount of change in the output to the amount of change in the input. So again, the rate of change is the unit rate, which is our constant of proportionality. The equation for this relationship may be written as y equals kx, where k is the constant of proportionality or the rate of change. So remember, we find what k is and we just plug it into this equation format. Now this relationship can be displayed in a table by writing a list of inputs, which are the x, and the corresponding outputs, which is the y. So if we want an example of what that looks like, this was our x and y. So our input and our output. Now we can use that table to graph, and those points are called the ordered pairs. And those ordered pairs from the graph, from the table, can be graphed on a coordinate plane. So that's what we're adding. We're adding our graphing. So let's look at the 4 ways in which we can see it. We're going to look at all 4 representations here right now. So the first way to see it is in a word problem situation. And ours says, James sells 3 pencils for $2 to the kids in his neighborhood. What is the rate of change? So again, asking for the rate of change is like asking for the unit rate, okay? So let's go ahead and make our table. I know that if he sells 0 pencils, that's $0. And proportional relationships always start at 0, 0, okay? Now if he sells 3 pencils, we know that that is $2. If we sell 6, we know that that's $4. And if he sells 9, we know that that's going to be $6. Now we can graph these ordered pairs in the graph. So again, we have a word problem, our table, and now we're going to have a graph. So my first point is 0, 0. Then I have 3 pencils for $2. Then I have 6 pencils for $4. 1, 2, 3, 4. And then I can have 9 pencils for $6. And this makes a straight line. Now we can go ahead and find the rate of change, or K, right? It is our constant of proportionality. Now remember that in order to find that is y divided by x. So what we can actually do is take any point and that point is 2 and the x is 3. So it matches the table, okay? But if you're given a graph, you can just graph any point and take that coordinate and use that for your x and y. So my y is going to be 2 and the x is 3. So y over x will actually be 2 over 3. Now, I'm going to leave it as a fraction. Remember, if you get repeating decimals, just leave everything as a fraction, okay? So these are the 4 different ways in which we can look at a proportional relationship. We have a word problem, a table, a graph, and an equation, okay? So let's go ahead and do an example. Here we go. Here's the first representation. Nina reads 2 books every 5 days. What is the rate of change? So this is the first way in which we can see a proportional relationship, and it's just in words, okay? It's describing. Now let's go ahead and make a table. Here's x and here's y. Okay. Now x is always going to be time. So in 5 days, she reads 2 books. So that means that in 10 days, she reads 4 books. And in 15 days, she reads 6 books. So these are all proportional relationships, okay? Let's go ahead and graph that. So we've seen the table, the word problem, and let's go ahead and hit the graph. Now we need to make sure that we are labeling our graph. These are our days. These are our books. And in 5 days, she reads 2 books. In 10 days, she reads 4 books. And in 15 days, she reads 6 books. And we start at 0, right? 0 days, nothing has been read. There we go. So that is our graph for proportion. Now in order to write the equation, remember that we first need to find k, which is y over x. And from a graph, you can take any point. It'll actually work with all of our points, which is the same as picking the table, okay? Picking a point is just like picking the points on a table. So remember that this is our x and this is our y. So I'm just going to refer to the graph so that you guys see it a little bit differently. So if I pick this point, the y will be 4 and the x will be 10. And if we simplify that, we will get 2/5. If I pick this point, the y is 6, the x is 15, so remember y over x. And again, it simplifies to 2/5. So once we have found our k, our constant of proportionality, remember all we have to do is just plug it into our equation to give us our last representation, which is an equation format. So our equation will be y equals 2/5 x. So now we have all 4 representations: a word problem, a table, a graph, and an equation.